You ready, Rye? Woohoo. Says this, lesson 1, review of trigonometry. What I want to do is get you good enough at Sohcahtoa right angle trig that it becomes boring, that it's almost as easy as going 6 times 8 on your calculator. If you get there, I've done my job. If you get bored with this, I've done my job. In fact, in Physics 12, we really do a lot of trig, and we push kids to try and do some of it in their homework without showing all their steps. Always write it out on tests. Example 1. Oh, trigonometry literally means triangle measure, the study of triangles, 3-sided measurement. It says find the length of a missing side. We're going to, during this lesson, be looking at what we call right angle trig. Right angle trig means you've got a right angle, a 90-degree angle, somewhere in the diagram. If you don't see that symbol, but it looks like it's 90 degrees, for today's lesson, assume it's 90 degrees. And Mr. Dewitt forgot to put that stupid symbol in because you'd be amazed how tough it is to get that when you're trying to do graphics. Anyways, how could I find the length of this missing side? You learned this one in Math 8. It's a theorem. Pythagoras. So you can write, in order to use this, in order to solve this, we use Pythagoras. What is Pythagoras' theorem as an equation? It's kind of alphabetical, so it's one that, if you ask adults which equations they remember from high school, typically it's Pythagoras and sometimes the quadratic formula. There was that one with the plus or minus thing. What's Pythagoras? Okay. And for this to work, what's the only thing you absolutely have to remember about that there? Well, there's squares on all 3. What has to go there? Okay, this is key. If you don't know this, the thing that has to go where the letter C is the hypotenuse, the long side. I see too many kids just think, oh, that's where the x goes. No, only if your x is sitting on the hypotenuse. In other words, if we solve this question here, what would I write as an equation for this triangle that has a 55, an x, and a 73? What squared plus what squared equals what squared? It's Math 8, people. Wake up.
55 squared.
There we go. 55 squared plus, sorry?
X squared.
Equals 73 squared. Mr. Dewitt, can I cancel out all these squares? No. Can't I just square root everything right now? No. We want to get the x squared by itself. How would I get the x squared by itself? Boy, see how that formula manipulation even works here too? So you're saying you do that? Now that gets an x squared by itself, Matt. How do I get the x by itself? How do I deal with a squared? So in terms of the amount of work, I'm totally fine if you just do that. Okay? In fact, I'll be honest, I'm fairly fine if you get so good that you can do this all on your calculator. Now in math, typically they want you to leave it in simplest radical form. 8 root 9, 8 root 5, 5 root whatever. In physics, we want decimals. Let's go to 2 sig figs, maybe even 3. Or will this work out evenly? I don't know. So to type this, you'll go 73 squared minus 55 squared. You'll hit equals, and you'll go square root answer button. Holy smokes, it works out evenly. That's a fluke. No, it's not. It took me a while to find that one. And I guess we'll add some units, centimeters. So one of the tools we're going to be using an awful lot is Pythagoras. Pythagoras. This one won't work out evenly. Find it. I'll do it slowly up here, but try this on your own with your calculator out and in front of you. Out and in front of you. Oh, got a latecomer. Hang on here. We'll pause the video. I think I would go like this. X squared plus 7.6 squared equals 19.3 squared. Yes? If in your homework, I would not do this on a test. On a test, I would show as much work as I did on the previous example. If in your homework you are comfortable now going 19.3 squared minus 7.6 squared, if you're, oh, let's try that again, square root, answer button. If you're comfortable, is it 17.74? Okay. If you're comfortable doing that, I'm fine with that. In fact, I'm even going to go like this. So if you can do it on your calculator, I'm okay. Pythagoras. The second big tool we have is what you think of as trig. Pythagoras is part of trig because it's used to solve triangles and sides, but is the trig functions, those three buttons on your calculator, what you may have called Sohcahtoa. And to do that, we have to be able to label sides. If we're dealing with this angle right here, all triangles have three sides, and if they're right-angled triangles, if they have a right angle, we say that the three sides are called opposite, adjacent, and hypotenuse. The long, skinny, diagonal side is that, and we label that with a little letter H. Yes? This short vertical side, what's that? The horizontal side. Now, of course, that changes depending on which angle we're talking about. Don't write this next bit down, but if we were looking at this angle, that would be opposite. That would be adjacent. The word adjacent in English means beside or touching. If you label or see the hypotenuse first, this is the side that's beside or touching the angle. And the word opposite, right now, Sheldon and I are opposite each other. We're facing each other. Opposite is the one across from. Opposite. We also have three primary trig ratios. What are they called? Abbreviated SIN, COS, and TAN. By the way, it's sine, not sin. Sin is when you're late for my class. That's a sin. Sine is the trig function. And so when I was in high school, we were still just sometimes doing this pencil and paper the long way with tables and charts. You guys have this all built into your calculators. Get out your calculator, and the first thing you want to do is you want to evaluate the following. Find the sine of 42, and if you don't get the same answer as me, it means your calculator is in the wrong mode, and we need to fix that. So if you go sine of 42, you should get 0.66913. I'll go to 5 sig figs, 0.66913. If you didn't get that, now is the time to ask. You got that okay, Leash? Yes? Everybody got that? Okay, if you didn't get that, now is the time to ask. So let me rephrase that. If you didn't get that, get my attention, raise your hand, make a noise, do something. Okay, let me make sure your calculator is in the right mode. Pause the video for a second. Find the cosine of 76, please. .24192. And for when I'm doing trig, I tend to keep a lot of extra sig figs. I want to be accurate. 0.24192. Tangent of 45. This one I've memorized. Double check me. One. Yes? Tangent of 90. Undefined. Speaking of undefined, another late young man. Come on in. Pause the video. All of you get your calculators out. So when you found the tangent of 90, you got an error? Curious what's going on there. Hey, let's find the tangent of 89 degrees. What's the tangent of 89? What do you get? 7 point. How about what's the tangent of 89? Let's sneak up to 90. In calculus, we call this doing a limit. What's the tangent of 89.9? 500 and something. What's the tangent of 89 point and then 4 nines after the decimal point? 89.9999. What's happening as we get closer to 90 degrees? What's happening to our answer?
Getting bigger.
Getting way bigger. You know what? Let's go tangent of 89 point and then 8 nines if you're or fill your screen with nines except for the big graphing one. And then hit equals. What do you get? Something in scientific notation, I'll bet? Anyone?
Yes.
What do you get? Huh?
A big number.
Times 10 to the what on the right-hand side? Times 10 to the what?
12.
Okay, you know what? It turns out as you get closer and closer to 90 degrees, the tangent graph shoots vertical. And so really, if you force me to say what is the tangent of 90 degrees, we would define it as infinity. Hashtag nerd trivia. So the point of this, Trevor, is if I give you an angle, Lydia, you can find me the sine or the cosine. If I tell you the sine or the cosine or the tangent, your calculator can give you the angle. We can go backwards. So if the tangent of mystery angle theta, we typically use the Greek letter theta as a variable for an angle. It's sort of shorthand. If I see an x and a y, I think maybe it's from a graph. If I see an A, B, and C, I think maybe it's from Pythagoras. If I see a theta, I think maybe it's from a triangle. So if I took the tangent of theta and I got 3.732, what was my original angle? How do I find that? How do you go backwards? It's going to vary from calculator to calculator. Some of your calculators will call it an inverse button right here. Some of you will have a shift button right here. Some of you will have a second function right here. Mathematically, we call it inverse tangent or arctangent. So on your calculator, press whatever button that is, tangent of 3.732, and your calculator will tell you that the angle that we started with was? Really, what did I start with? 75 degrees. Usually for angles, I go to the nearest degree or at most 1/10 of a degree, because 1 degree, remember there's 360 degrees in a circle, 1 degree is only about barely, you can barely see my arm move if I'm tracing out 1 degree. So I'll go to maybe 1/10 of a degree, and even that's crazy accurate. Okay. Solve the following to the nearest degree. Suppose you know that the sine of mystery angle A is 0.5. What's angle A? 30 degrees. Suppose you know that the cosine of mystery angle theta is 0.5. What's angle theta? I think this one works out evenly. 60 degrees? I picked some nice ones there that worked out nice, but they don't all. If the tangent of theta is 0.4877, what's angle theta? Sorry? 26 degrees? Okay. I will be fussy. Degrees are a unit, and I am fussy on units, so put the little degrees symbol there. A bit more, hopefully none of that's new. Hopefully that's all Math 10. Yep. So you should be acing this. And then we have the definitions of sine and cosine and tangent. We have this acronym that we use called Sohcahtoa. In fact, often I write Sohcahtoa at the top of a page when I'm doing trig, just so I don't have to remind myself. Sine, and the Sohcahtoa means sine is defined as opposite over hypotenuse. Cosine is defined as the length of the adjacent side divided by the length of the hypotenuse. Tangent is defined as the length of the opposite side divided by the adjacent. And with that, we have one of the most powerful tools in all of mathematics and easily applied to physics. We can start to find missing lengths. Example 6 says, determine the length of the indicated side to the nearest 0.1 centimeter. I'm going to zoom in. All right. Can I give you Mr. Dewick's no muss, no fuss, minimum amount of work, maximum amount of success method for solving trig? Okay? First thing I do, you may have noticed, Trevor, I enjoy writing something down mindlessly because it relaxes me. Honestly, the first thing I almost always do is I put a little color in the angle that I'm talking about, just so I don't stupidly pick the wrong angle. That never happens? Yeah, it does. You're in a rush and okay? So I do that. I feel better. How many sides have stuff on them? 2. This side is blank. I'm going to leave it blank. I'm not going to label it unless I have to because it's a waste of my time. Some teachers I know teach label all 3 sides. I don't say this very often, but I think that's bad teaching. It's confusing. You only label the 2 sides you're interested in. This x, opposite, adjacent, or hypotenuse? Put the letter O there. This 15, opposite, adjacent, or hypotenuse? You see, I think if you only label those 2 sides, it's very clear which trig function we want. We have an O and an H. Some teachers will also have you put an A there. To me, now it's more confusing. You've added an extra letter. No. Which trig function has the O and the H in it? Sine, not sin. So I do that. I write down the trig function, and then I say to myself, what always goes next to the trig function? The angle. Always. What's the angle here? Equals opposite over hypotenuse. I want to get the x by itself. There's a 15 on the same side as the x. How would I move that 15 over? What's the 15 doing to the x? I'll multiply it over. X equals 15 sine 7 degrees. $12.6. I think they said to the nearest 0.1, right? And I guess it's centimeters. Mr. Dewick, what's Sarah? How much of this are you going to make us show? Sarah, I'm insistent that I see that line. I'm actually kind of thrilled if you can go straight to the answer on your calculator from that line without showing the middle step. I think that's called becoming an expert. So I'm okay with that. Now, the risk I take is because I always give you the answers that some meathead could just copy the answer. Don't do that. B. I feel better. The 11.1, opposite, adjacent, or hypotenuse? The 11.1, opposite, adjacent, or hypotenuse? Opposite. What about the x? Adjacent. I'm not going to label the hypotenuse. It just makes it confusing because it gives me an extra letter to worry about. Right now, I have an O and an A. Which trig function is the O and the A? 10. What always goes next to the trig function? The angle equals 11.1 over x. What's the difference between B, example, and A, example, where the x is? X is on the bottom. These are the only 2 possibilities you're going to get if you're finding a side. When x is on the bottom, what happens? How do you get the x by itself? We can't solve with x on the bottom. So we're going to do this one the long way, and then this is one of the few times, Haley, what I'm going to say, it's worth memorizing the pattern because you're going to use this so often. And hopefully by now, Haley, you've had me long enough to know if I say something is worth memorizing, it's really worth memorizing, because otherwise you're going to be doing extra work, extra work, extra work, extra work, extra work. Haley, where is the x right now? It's dividing. Dividing by x on this side is the same as doing what with the x on the left side? In my mind, and we're going to write this right now, the next line says this. That line is much nicer because now, Trevor, x is on the top. Yay! except we haven't got the x by itself. There's a tan 28. What's that tan 28 doing to the x? Multiplying. How would I move it over? X is going to be 11.1 all over tan 28. Which is what? And this is where you have to figure out how your calculator makes you type these things in. Some of your calculators, if you have a crappier one, you'll go 11.1 divided by 28 tan button equals. Hopefully I've gone on a rant occasionally about getting a good calculator. 20.9? Okay. And this one is also centimeters. Ready for the shortcut, Haley? Yeah. I'd like you to look at that and that. Okay? Here's what I do. In my mind, I always like to have everything fractions or nothing fractions. In my mind, I see that. Don't write that down. But in my mind, I see that the left-hand side is over 1 over. And what I really want to see is there's a top on each side and a bottom on each side. What I really want to see, Ryan, is 1 fraction equals 1 fraction. Do I have 1 fraction equals 1 fraction? Yeah. You know what I've learned a long time ago? You guys call it cross-multiplying, but I actually take it one step further. I have learned that whenever I have 1 fraction equals 1 fraction, do I have 1 fraction equals 1 fraction? Stuff moves diagonally across the equal signs. In other words, that's going to move up to there. And in other words, that's going to move to there, that's going to move to there. That's worth having in your back pocket because it's a huge time saver. If you got 1 fraction equals 1 fraction, stuff moves diagonally. Then you can kind of track it all in your head by just drawing a couple of crisscross lines and go straight to the next line. And you may have noticed I have a fondness for good shortcuts that are organized but lazy. Okay. Use this to find angles. Says, determine the measure of the indicated angle to the nearest degree. They want us to find angle x. Mr. Duick says, color in the angle that we're interested in. Okay. Let me zoom in again to this. How do I find an angle? I still start out by labeling sides. That 15, opposite, adjacent, or hypotenuse. That 15, opposite, adjacent, or hypotenuse. It's a hypotenuse. That 7, opposite or adjacent. Which trig function is cos? What always goes next to the trig function, the angle? What's the angle this time? Okay. X equals adjacent over hypotenuse. Yes? How do I solve these? How do I find an angle? We talked, yeah? Hang on, even before that, how do I find an angle? We mentioned this about 10 minutes ago. Prith was the one who told us. This is going to be the inverse or the shift or the, okay. It's going to depend on how your calculators work, but Matt, you know I'm lazy. What most of you will have to do is go shift or second function cos, and you'll have to open up a bracket. So can you go shift or second function or inverse cos bracket, 7 divided by 15, close bracket. You can do it all in one step. You were going to say, Mr. Duick, do I go 7 divided by 15 and then shift cos that? You can, but that's extra typing. So if you want to do it all in one step, bracket, close bracket, and to me that looks clean, and also I can compare it to what I have on my paper and say, oh yeah, and I get theta is, or angle x is 62.2 degrees. Yes? $62.2 degrees. What's my angle here? What variable is my angle here? What variable is my angle here? What variable is my angle here? Because I asked you to. Why? Because I asked you to. Did I just lose my projector for a second there again? Did it flicker? God. Stay strong. Get me to the end of the year. Okay, color in right there. That 8.1, opposite, adjacent, or hypotenuse? Yeah. 14.5, adjacent or hypotenuse? Sorry? Not adjacent? Oh, you're right. You got to be careful with the long, skinny triangles because the adjacent and the hypotenuse sometimes look a little alike. But yeah, okay. So hypotenuse, which is always across from the right angle. Which trig function? What always goes next to the trig function? The angle. Why? Because I asked you to. I'm sorry, but I'll never get tired of that joke, Cohen. It's sad, but... How do I find an angle? Second function or inverse or shift or whatever it's called in your calculator. And because it's a fraction, I'll have to put it in brackets. Second function, sine bracket. My calculator automatically opens up a bracket. Some of yours might as well. Rebecca's, yours will. Divided by 14.5. So Rebecca, for you to remember, anytime that thing resets, you'll have to go into mode and go back to degrees. I was going to say 33.9. Would 33.9 be rounding off properly? No. I guess it's going to end up being 34.0. Yes? Y equals 34.0 degrees. That's almost the end of the lesson. In theory, that's all review. I just want to give you two common physics terms. The common physics terms are angle of elevation versus angle of depression. Okay? If they talk about an angle of elevation in a problem and you're drawing a little picture, the angle of elevation, if you draw a little dotted line like this, you raise your eyes. You elevate your eyes. Come on, stay. For those of you at YouTube, my projector is on its last legs, but I'm keeping it alive. Okay? So if you have question talks about find the angle of elevation, when you draw your picture, you're looking for the one that goes from the horizon upwards. I can't say from the ground up because you might be standing on a cliff, but probably from the ground up. Then there's angle of depression. And I always say it that way because this helps me remember what to do. Angle of depression. Draw a dotted line up here. Here's the horizontal line. When you're depressed, look at me. I'm depressed. You lower your eyes. So if a question asks you to find an angle of depression, you're probably going to the top part of the diagram somewhere. I have to be very vague because it varies from question to question to question. But you want to think, oh, depressed. Lower your eye. Find that angle, the angle that requires you to lower your eyes. There's a couple of word problems in the homework. What's your homework? You can get it done in class pretty easily. I did attach the answers not next to each question, but the answers are attached here at the very, very end. This is also kind of, I gave you a printout, a day for you to track any missing assignments and hand stuff in.